Hi, it's time for another soldering repair video. Now, ever since those LaCroix videos I did where I was trying to repair the LaCroix oscilloscope and I ripped off this huge quad flat pack ASIC rather brutally and medieval actually, because I didn't need the chip again, and so yeah, I just cut the pins and ripped the damn thing off. And a lot of people said, well, why don't you use ChipQuik? And well, I don't have any ChipQuik. So the makers of ChipQuik, they must have thought the same thing. They've sent me some. So let's give it a go. This low melting point ChipQuik repair stuff. And it's supposed to be just that. Low melting point solder that you can put on your chip so that you can heat up all the pins at once and safely remove the chip without using a special hot air attachment, which is the traditional method for getting off a large pin count quad flat pack. Is it any good? Hey, we'll find out. And here it is. It's the ChipQuik patented SMD removal kit, SMD1, and well, it's about $16 or something like that. Might be more or less depending on where you get it from, in what country. And what you get is a bit of flux in a little tube there. ChipQuik flux, SMD 291 no clean paste flux. I don't think there's anything special with that flux. It's just a regular gel type flux. You could probably use any main type of flux you like. And there's some of the low melting point solder alloy, the special patented alloy, which is what it gives this thing its magic, apparently. And you get some 70% isopropanol alcohol wipes as well. No big deal, but that's the alloy you're paying for. And apparently it's very expensive stuff. If you want to buy a lot of it, it's not cheap at all. So use sparingly. So apparently this is enough to do like 8 to 10 chips, they claim. Depends on the size. And it's apparently really easy to use. You apply flux to all the leads, you melt the ChipQuik alloy on all the pins, and you heat it up and maintain that alloy in a molten state so you can remove the chip and just take it off with a pickup tool. That's it. Is it that easy? We'll find out. And if you want to get these 70% isopropanol wipes, pretty handy things to have around the lab for all sorts of purposes, not only cleaning boards, but for cleaning all sorts of stuff, then you can get them from your local chemist in large boxes like this. Exactly the same stuff. They're for medical uses, cleaning down your skin and stuff like that before you, inject yourself or do something like that. So available cheaply at any chemist or drugstore for you Yanks. And here it is up close, the special ChipQuik patented at low melting point alloy. How low? Well, they claim it's around 58 degrees Celsius. Crikey, that's like as hot as my old lab used to get in the middle of summer here. And here it is, compared to regular 60-40 tin solder. It looks a bit shinier and brighter. And as you can see on the end there, it's actually broken off. It's pretty brittle, this stuff. If you have a look at regular solder, it's not very brittle at all. Of course, you can bend it like that, all sorts of ways, and, it really takes some breaking. But this ChipQuik stuff, that just broke straight off. Now, they're not actually telling you that I could find anyway what sort of alloy this is and why it's patented. I mean, I'm sure it's been done before. They also sell low melting point solder paste as well, but that's just regular 42% tin, 58% bismuth paste that you can get from many different manufacturers, and that has a lower melting point, 130 something degrees, 138 degrees, I think, something like that. But they claim this wire alloy does 58 degrees Celsius. Woo! So, does it melt at a very low temperature? Well, let's find out. I've got my hot air gun here set to 100 degrees Celsius because all of my soldering irons only go down to a minimum of 200 degrees Celsius. So, here it is, around 100 degrees on the hot air. Let's have a look. Is that starting to do anything? I don't know. Not sure. Doesn't, no, 100 degrees doesn't seem to be... Oh yeah, look at that. There you go, that's only 100 degrees Celsius. Brilliant. And let's see how long it stays molten at 100. Look, it's still, even after a couple of seconds, is still pretty molten. Wow. So let's compare it with regular 60/40 solder and see how long it stays molten at a higher, a regular soldering temperature. So I've got my JBC iron here set to 280 degrees, which is, a fairly average low temperature for a soldering iron. So the top one is the Quik chip, and the bottom one is regular 60/40 lead solder. So let's keep that molten. There we go. Let's leave it there for a few seconds, and as you can see, it stays molten for, I don't know, for 3 or 4 seconds, something like that, without any major thermal effects. Maybe a little from the ground plane underneath there, but yeah, it doesn't stay molten very long. That means that on a big quad flat pack, you can't just heat up all 4 sides at once with your regular soldering iron and expect to be able to desolder it. By the time you get around all 4 sides, it's gone. So let's compare that to the ChipQuik. Here we go. Look at that. So let's heat that up, leave it there for a couple of seconds, and it is still molten. 3, 4, 5, 6, 7, at least twice as long. And of course, the way this stuff works is if you combine it with regular solder, then it lowers the melting point of the whole alloy, of course, because you've effectively changed the alloy. You've added whatever alloy is in here to this alloy, and you've created a composite alloy. So let's try that. Let's bring this over and put that all in the... So we've added our ChipQuik to regular 60/40 stuff, and let's give that a go. And as you can see, it stays molten for longer. So let me just add more to that. More ChipQuik in there. There we go. And so we'll keep that all molten, and as you can see, it still stays molten for a fair amount of time, and then it starts to really go crystalline and stuff like that. So what good is that? Well, let's say we wanted to remove, without damaging all the pads, this huge Spartan FPGA. It's an XC30S in a 208-pin quad flat pack, 52 pins per side. It's quite a large one. You don't get too many bigger ones than that, so it's not a bad example at all. How would you normally remove this? Well, you would normally remove it with a specific hot air attachment that actually blew hot air over all 4 sides. And you usually, if you want to do it properly, you buy a hot air attachment that is designed for your specific size chip. So if you've got a hot air gun, you usually need a whole bunch of attachments for your specific chip, which is okay for a big company or something like that, for a known product that you have to remove all the time. But just one off, well, how do you do it? It ain't easy unless you got this ChipQuik, or you go along like I did in a previous video and physically cut all the pins off like that. But you've got to be careful that you don't actually cause damage to the chip. But with this ChipQuik, we should be able to put solder. The idea is put solder on all 4 sides of this chip, and it'll stay molten long enough on all 4 sides to lift the chip off. That's the theory. Alright, now let's give this a go. Now we're going to need a pickup tool to, a vacuum tool to extract this off once we melt all the pins. Now, if you don't have one, cheap and easy solution, some blue tack like this, whack it on the end of a screwdriver. It's nice and tacky, very low cost. You can stick that in the middle of the chip like that, and you should be able to, I can lift that whole board up, so we should be able to easily lift that chip off. Alright, let's give it a go. It's supposed to be easy. Now, bear in mind, this is the very first time I've done this. I've never used ChipQuik before. I haven't practiced, so I'm doing it first time exactly as you would. Perhaps, I'd highly recommend if you get an important part, you practice. But anyway, let's put the flux on all the pins there. And as I said, it probably doesn't matter what flux you use here. Alright, so we have the flux on all the pins. Let's get my iron chisel tip, of course, and I've set it, you don't want it too high, I've set it for about 280 degrees or thereabouts, Celsius. By the way, everything I say is in Celsius, because you don't want to get it too hot and lift off the pad. So it's a bit of a compromise between how hot you get it to how long it stays molten to risk of lifting those pads. So anyway, here we go. Let's give it a go. I expect a lot of fuming for the all the flux in there, but we really need to use a fair bit of this to get on every pin along there. So, and be careful you don't put too much pressure on this, by the way. Blow those fumes away, because you don't want to lift any of your pads or your pins. So just don't put any pressure at all, really, on your iron. You're just trying to add solder to those pins. So, oops, I just broke it off. It's very brittle stuff. Let me go around and add solder to all these pins, and we might come back, and then we'll go around and reheat this stuff and see if that chip just lifts off. And here we go, the moment of truth. Once again, my iron's set to 280 degrees. So I'll go around and heat up all these pins. Once again, being very careful not to put pressure on those pins at all. And going around, keeping it all molten, while supposedly I don't feel it coming yet. No, it's not coming yet. It seems to be staying molten on all sides, but no, maybe I need to give my chip a good week. Oh, there we go, it's coming off. Woohoo! Look at that. Beautiful. Now that, and you can see the solder is still molten there. Quite a few. Look at that, jiggle, jiggle, jiggle. Quite a long time after the fact, because there's still a lot of thermal mass. I mean, look at that. Wow. I could probably get rid of those balls, actually. But anyway, you don't want to do that. I don't care about this board, but if you wanted to, you wouldn't do that. You'd get it all over your board. Look at that, but that stayed molten for an awful long time there. And look, even on the chip here, it's still molten. But, so that's, like 30 seconds later or something like that, easily. So getting it up to 280 degrees, probably didn't need 280 degrees, of course. So we probably could have done that with a lower temp just to avoid damaging the chip, especially if you wanted to reuse the chippers or something like that. You probably could, clean up those pins perhaps and reuse it, but geez. Anyway, the whole idea is to get the chip off so that you can clean up the pads, solder on a new one. That's a win. Now to clean up these pads, ChipQuik recommend going around with a cotton swab and actually a low temperature iron and clean them up, dab isopropyl alcohol, clean them up that way. They don't recommend solder wick, but I'm going to use solder wick iron. I've got it set lower to 250 degrees Celsius, so some of this, I mean, we can just get rid of the big balls like that easily. And because it's still, look at that. It's just beautiful, this stuff. Look, so you don't actually have to use your solder wick to clean that up, just blob it all together like that, and then you can just peel that off. Let your solder mask do the work there, but then you want to go around, clean your pads, do it using solder wick. The regular rules apply to very low temperature, of course, to ensure you don't damage any pads. I think we may have had one little pad damage down there. Well, maybe it's a bit high. Maybe I was accidentally moved it with the iron, actually accidentally hit that pin with the iron or something like that. But anyway, it's the first time I've ever used this stuff. It worked well. So as you can see, yes, one little tiny pin in there is bent, so maybe I was, my iron accidentally touched that. Once again, doing this under the camera wasn't probably optimal angle. I wasn't spinning my board around and stuff like that to get the optimum iron angle, but apart from that, there are no other pins lifted. So I declare that, folks, to be a win. Just have to clean up some of the pads, because one of the keys of reworking stuff like this is you need to get all the solder off those pads, because you need it completely flat, or as flat as you can get it, when you put your chip down again, especially for large pin count, fine pitch devices like this one. So, and of course, this ChipQuik stuff is probably not ideal if you're doing, you know, mil spec or NASA spec soldering or something like that, because you've added this alloy. Check out that. It's sort of like a frosted sort of, look at that. So you've added this unknown alloy to your solder, which is then going to be mixed on these pads. Even if you clean it off, there's still going to be some left on there. So now, even when you apply fresh solder flux and put the chip back on, you've still got some of whatever that alloy is left in your joints. And does that make them brittle? What does it do for, you know, long life, tin whiskers, all that sort of thing? So, you know, but you don't really have to worry about that for, you know, sort of, you know, hobbyist or one-off type stuff. It's only if you really take your soldering extremely seriously. And if you are using solder wick like this, don't make the common mistake of putting your soldering iron on and then dragging the thing across. That's bad. You're just going to lift the pads. You should go through and just dab each one like that and then move along, move along. Yeah, it takes longer, but you're not going to lift those pins off, because if you drag that abrasive solder wick across your pins, you're just going to lift them. Really, even if you've got a relatively low temperature on your iron, don't do it. Even though I don't have a new chip to solder on. Sorry, I've already done soldering videos on a couple of different methods to do quad flat packs like this, using drag soldering and also paste reflow method as well. So I'll have to link those in if you want to see them. But apart from that, there we go, folks. We are almost clean. There was a little bridge in there. Anyway, let's not fuss. And to clean all that flux residue off there, you can get in there with your isopropanol pad and wipe it off. But these aren't the best things. I'd highly recommend getting your isopropanol PCB cleaning spray. You can just buy it. It's the same stuff. It's isopropanol alcohol, or you can get the Flux Clean brand stuff and things like that. Clean it all up. And there's our leftover chip, and as you can see, no pins damaged at all. You could, you know, there's a few pins pushed to the side or something like that, but in theory you could just get rid of that solder, wick that off, and probably reuse that chip if you really needed to. Alright, now I've got a little bit of practice on that. Let's try it again in real time. Little tiny quad flat pack here. Bit of flux on the pins. We'll do this in real time. See how easy it is. And it's a much smaller chip, so the thermal mass is much smaller that we have to keep molten. So let's go in there, apply our solder on all sides. Yep. There we go. Be careful if you've got nearby passives, of course. You don't want to lift those or cause an issue there. And where's my tool to lift up? There we go, gone. And the good thing is we can just lift the excess stuff off those pads, no problem at all, and that was far too easy. Man, instant. I like this stuff. It works. And as you can see, I don't have much left after doing that that large 208 pin quad flat pack or the smaller one. So, you know, it doesn't go very far at all. And really, you know, it's not cheap stuff, but it works absolutely perfectly. There's no damage to those chips. Trivial to remove them. And that was not some practiced perfect soldering tutorial there, folks. That was the first time I've ever used it on a large 208 pin quad flat pack. I didn't know what I was doing, and it worked a treat. So certainly well worth having some of this stuff in your kit. definitely, I'm going to buy some. Oh, I've got some left, but I'll probably buy some more to keep in the kit just for those emergencies when you have to remove these types of chips, and do it properly. Highly recommended. So I hope you enjoyed that. If you want to discuss it, jump on over to the EEVblog forum, and if you like these types of videos, please give them a big thumbs up, and I'll link in some of my other soldering videos as well. There'll be a playlist there, and I've got a whole bunch of them. Catch you next time.